Alright guys, so today we are talking about the normal distribution curve. So we've talked about the normal distribution curve before, and I suppose how a lot of data, when you input it, it always comes out to represent this. Okay, and I suppose a nice example would be everybody's shoe size. So again, you have the few that are out here that would be really small feet, quite big feet, and then you have the general consensus that everyone else is somewhere in the middle. So it's a pattern that shows large numbers cluster near the middle of the distribution. If the distribution is very large and continuous, and the class intervals become sufficiently small, the distribution forms a symmetrical bell shape. Okay, and this is what we call the curve of normal distribution, or the normal curve. The normal distribution is the most important continuous distribution in statistics. The curve on the right shows the normal distribution with the mean, and the mean is represented by this symbol here. Now previously we spoke about the mean of a sample, and the mean of a sample is x bar. But the mean of a population, which is obviously what we're talking about here when we're talking about the standard deviation, is actually given by this symbol, which is pronounced mu. All the normal distributions will have a mean, so mu, and a standard deviation. So this is the symbol we use for standard deviation, which we know to be this symbol here, which is sigma. Okay. So different values for mu and sigma will give different normal distributions. So sometimes the normal distribution curve can look a lot flatter, okay? And then sometimes it can look like this. So here we can see that the mu is 20, so the mean is 20, and the standard deviation is 5. Here we've got the mean is 20 and the standard deviation is 10. The diagram on the right shows two normal distributions with the same mean but different standard deviations. So this diagram shows two diagrams that have the exact same distribution but different means. So same standard deviation, they both have standard deviation of 5, but a different mu's or different means, in this case 20 and in this case 30. Now, the next thing we're going to look at is the empirical rule. So it is a very important rule that when we're dealing with normal distribution curves, all of these satisfy it. So they share some important characteristics, and these important characteristics we refer to as the empirical rule. So the first one is, if you were to find the mean right here, and if you were to find the mean minus 1 standard deviation, so if you have this, that's the mean minus 1 standard deviation. If you have this, that's the mean minus 2 standard deviations. So in this case here, we're looking at the mean minus 1 standard deviation. If you were to colour all of that in, that actually represents 68% of the data. And this is an important number, okay? Because 1 standard deviation away from the normal distribution curve is 68%. About 95% will then be found between the mean minus 2 standard deviations. So essentially it is 47.5% each. So it's really important that we remember this. So the first one, if it's the mean and 1 standard deviation, it's 68%. If it's the mean and 2 standard deviations, 95% of people will be in that. And then the last one is almost 99.7% of the values lie within the mean and 3 standard deviations. These 3 characteristics of the normal distribution are generally known as the empirical rule. So I would remember that the empirical rule for the mean minus 1 standard deviation is 68, the mean minus 2 standard deviations is 95, and the mean, just get my pen to work, the mean minus 3 standard deviations is equal to 99.7%. Those numbers are important and need to be remembered. Okay, so we're looking at a question now together. The frequency table below shows the number of hits a website received each day during a particular week. So the first thing we're asked here is we're asked to calculate mu. Okay, so in our case we know what that is. Calculating of mu is calculating the mean of the normal distribution. Okay, should be able to do that nice and easily. So the mean equals, so I'm going to add up all of the numbers. And 1, 2, 3, 4, 5, and I'm getting 62. Okay, so we have the mean. We are then asked to find sigma, which is the standard deviation. So the standard deviation of sigma, we've done 2 lessons on this now at this stage, okay? So I'm not going to go over that, but you're going to find the answer. I want you to test it to make sure that you got it right, but the answer here is 34.87. So we're then asked to find the range, and we're asked to find the mean minus 1 standard deviation and the mean plus 1 standard deviation. So we're going to be able to do that. That is exactly, what is that? The mean minus 1 and plus 1 of our empirical rule, remember that's 68%. So 68% is going to be 62 minus 34.87 and 62 plus 34.87. So let's get some answers. And so I can say 68% of the people are between 27.13 and 96.87. And when we're given our answers with this, we kind of do our square brackets. Okay. Okay, the next question. The distribution of heights of a large group of students is normal with the mean of 158 centimetres. So they're telling us the distribution is normal distribution. I'm already thinking empirical rule. Standard deviation from the mean is 10 centimetres and the mean is 158. So let's write that down. I've got the mean, just make my symbol a bit clearer, equals 158, and I've got the standard deviation is equal to 10, and they're both centimetres. The empirical rule says that 68% of the normally distributed population lies within 1 standard deviation of the mean. Okay, use the empirical rule to find the range of heights within 68%. Okay, so we know that 68% of the empirical rule is equal to the mean minus the standard deviation and the mean plus the standard deviation. So if that's going to be the case, it's going to be 158 minus 10 and 158 plus 10. And I'm getting 148 centimetres and 168 centimetres. So we're saying there that 68% of the people lie within 48 centimetres to 168 centimetres. Okay, got that one done. If a student is chosen at random from the population, find the probability that the student has a height of between 138 and 178. So we can see here that those numbers, guys, are bigger, or they're further away, aren't they? So I'm going to check and see, well, what is the mean minus 2 standard deviations and the mean plus 2 standard deviations, and see, does that get me in this age bracket, or sorry, in this height bracket. So remember, do you remember the number for 2 standard deviations? Okay, so again, hopefully you do, and it was 95%. So that would be the mean minus 2 standard deviations and the mean plus 2 standard deviations. Okay, so having done that then, let's have a look at what my answers would be. It would be 158 minus 2 times 10 and 158 plus 2 times 10. Oops. And my final answers there is going to be 138 and what am I going to get there? 178, which is what I wanted. So therefore I'm happy to say that find the probability. The probability would be 95%. You can also write it as a decimal, so 0.95 will work as well. Now again, I'm going through these quite quickly, so it is important that you're stopping the video as we go, taking things down, rewinding, figuring out where I've gotten my answers from. Okay, let's have a look at question number 3. The mean speed of vehicles on a road can be modelled by a normal distribution with a mean of 55 kilometers per hour. Okay, so mean equals 55 kmph and a standard deviation of 9 kilometers per hour. Right, okay, what do they want us to do? What would the speed of a vehicle that was travelling at 1 standard deviation below the mean? So 1 standard deviation below the mean would be the mean minus 1 standard deviation, which would be 55 minus 9. So the answer there is going to be 46 kilometers per hour. Okay, 2 standard deviations below the mean is going to be the mean minus 2 standard deviations, which is going to be 55 minus 18, which is going to give me, okay, I've just had a look, it actually says above the mean, so I need to add that, so it is the mean plus 2 standard deviations, and I'm going to get 73 kilometers per hour here. And then the third one I'm going to get here is 3 standard deviations above the mean. So it's the mean plus 3 standard deviations. So 55 plus 27, which is going to give me 82 kilometers per hour. Okay, and remember I'm getting those from knowing what 1 standard deviation is. Okay, so to just re-examine our curves for a little second, you can see here in this first drawing, this is the whole normal distribution curve, and the whole thing would add up to 100%. Okay, so with our empirical rule, we know that if we have the mean minus 1 standard deviation and the mean plus 1 standard deviation, that gives us a standard deviation of 68%. And if we were to just examine that, okay, if all of that green section here is 68%, then we can conclude that if this is the mean, that from the mean, or from the middle bit to 1 standard deviation away would be 34%, and likewise this would be 34%. And I suppose understanding this is going to help us as well. Now, we know that this is, if we were asked to figure out, okay, well, how much is in all of this bit here? Okay, and you know that this is the mean and this is the standard deviation. Well, you know that if you were to completely split the whole thing in half, that this section here, so this section that I'm covering in black, is going to be 50%. And then you know that if this is just 1 standard deviation above, remember that the whole thing will be 68%, then you would know that then from here to here is going to give you 34%. And so if I was asked to tell me how much would be in this whole red bit here, I would be able to say it would be 84%. So knowing our empirical rule also helps us figure out little parts of the normal distribution curve. So again, that's super important, needs to be taken down. Okay, so if the question was, well, how much is below 2 standard deviations? So we know the whole thing is 100%. We know from here to here is going to be 68%, and from here to here is 95%. So how much is below 2 standard deviations? So below 2 standard deviations means I would just be looking for this bit here, okay? So I need to, we know the whole thing is 100, so rather than finding out this bit here, it's actually easier to find out all of this. So we know from here to here is 50, and then from here to here is 2 standard deviations, so we know that that would be 95.6%. So if we divide that by 2, this bit here, so I'll do it in yellow, so this bit here would be 47.5%. So if I was asking for just how much is below 2 standard deviations, so this is the mean minus 2 standard deviations, it would be this bit here. I know the whole thing is 100, so I can then just subtract the 2, so it's going to be 2.5%. Okay, so one more. The marks out of 100 in an examination are normally distributed, okay? So we notice that and we recognise that it's a normal distribution curve. The mean mark is 60 and the standard deviation is 6. Remember, standard deviation is how far away you are from the mean. So my mean is equal to 60, and my standard deviation is equal to 6. Work out the mark that is 2 standard deviations above the mean. Okay, all right. So work out the mark that is 2 standard deviations above the mean. Right, so I suppose first things first is it is the mean plus 2 standard deviations, which is going to be 60. I just have my numbers up there, right? Okay, so it's going to be 60 plus 2 times 6, which is 12, which is 72 marks. Okay, so that's the first one done. Now, the second one says, what percentage of the marks lie between 48 and 72? Whenever we're asked about percentages, guys, I need us to think about the empirical rule. What is our empirical rule? We need to know those numbers off by heart. Okay, so they are the -1 standard deviation is 68%, the mean -2 standard deviations is 95%, and the mean -3 standard deviations is 99.7%. Okay, so we are asked first, what percentage lies between 48 and 72? Now, I actually have found that the mean plus 2 standard deviations is 72. So I'm thinking about my normal curve, okay? Okay, terrible drawing, but we get the idea. I know my mean here is 60, and I know that the mean minus the standard deviation and the mean plus the standard deviation, and then we've got the mean plus 2 standard deviations. Okay, very bad drawing, but we get the idea. And we know that the mean plus 2 standard deviations, we've actually got the answer there, is actually 72. So we want to find the difference between 72 and 48. So I'm going to check what is the mean minus 2 standard deviations. Let's see what that would be. It would be 60 plus 2 times 6, which would be 48. So that's perfect. So what percentage lies between 48 and 72? It is the 2 standard deviations, so the mean minus the 2 standard deviations. So my answer for number 2 is 95%. Okay, now what percentage of marks lies between 60 and 72? Right, so now we have to do a little bit of work here. I'm going to just pause this and clean up my diagram a little bit. Okay, so I have a much better diagram here, and we can see the normal distribution curve, and right down the middle is the mean. The mean is 60. Then we have the mean minus 1 standard deviation, the mean minus 2 standard deviations, and this should be a plus up here. Okay. So we're then asked what percentage is between 60 and 72%. So I really want to calculate that percentage. Okay, so I know obviously the whole thing is 100. I need to kind of split it into bits that I know. So I know from here to here and from here to here is 68%, isn't that right? Which actually means that this is 34% each way. So I actually don't need this side at all, so get rid of it. So I have first part here is 34%. Now, I know that from here to here is the second distribution, so it arrives for 95%, which means that this whole side here is 47%, and that this whole side here is 47.5%. Okay, so the question asked us to find the percentage of this yellow bit here. Let's call it this yellow bit, which is exactly from the mean over to 2 standard deviations, which is 47.5%. So I thought it was going to be a little bit more trickier than that. I thought we needed a bit more information, but we don't. Okay, so the third one. If 1,000 students took the examination, how many students scored less than 54? So in order to score less than 54, where would you be on the diagram? Okay, so I've just cleaned up my diagram a little bit. Now to find less than 54, we don't actually have 54 anywhere, but we obviously know it's in between 60 and 48. I actually haven't filled out the mean minus 1 standard deviation. Let me do that. So the mean minus 1 standard deviation, it'd be 60 minus 6, which is 54. Okay, so we know that this is 54, and we're asked, what's the percentage to score less than 54%? So we want to find all of this bit in the blue. Okay. All right, so now we're going to have to use a little bit more knowledge. Well, I know from here to the whole end of here is 50%, isn't it? Because it's completely down in half, so that's going to be 50%. And I know from here to here is 1 standard deviation. So 1 standard deviation both ways is 68%. So this is going to be 34%. So what is the chances? So this whole thing amounts, if I add those together, to 84%. So 84% scored above 54. How many scored less than 54? 16%. And then the question was, how many students? So they don't want a percentage, they want exactly how many students. So it's 16% of 1,000, which gives me 160 students. So lots of work in that question there.